This is example 4.1.4. It says determine the total displacement in direction a car travels if going 200 meters east and 100 meters north. Okay, so once again, when you've got these multi-directional problems, a lot of times it helps to draw it before you actually do anything else. So I start right here, and I go 200 meters east. Then I go 100 meters north. So I want to know what my total displacement is. Remember, displacement is where you start to where you finish. So that right there would be this direction right here. So that's what I want to know. What that is we've been calling that R, okay, or the resultant. You can also call it the hypotenuse, whatever you're more comfortable with, but that's basically what it is. The values that we're given is we're given that X is 200, and we're given that Y is 100. And really, since this is a right triangle, this is more of a math question than anything. What we're going to be using is the Pythagorean theorem. A squared plus B squared equals C squared. Now it doesn't matter what you define as A or B. I'm just going to call X A and Y B. The only thing that matters is really that C has to be the hypotenuse. So at this point we're going to go ahead and say, alright, C is going to equal the square root of 200 squared plus 100 squared, or in your calculator, 200 squared plus 100 squared. Take the square root of all that, and you get 223.6, which is the first part of our answer, 223.6 meters. Okay, so that's the first part of our answer. The second part of our answer has to do with the direction. Okay, remember, a vector is defined not only by its magnitude, but also by its direction. So when I'm trying to define where it goes, I need both. So in this case, I've got the magnitude taken care of, but the second part is finding the direction. So the direction would be the angle. Okay, now the formula that we gave you earlier was theta is equal to the inverse tangent of the opposite over the adjacent. And where that comes into play is the fact that you are given the opposite side and you are given the adjacent side, which allows you to solve for the angle. If you're given this and this, you would obviously use a different trig function. But this is the one that we primarily use because if we have these two, that's normally what we have. So when I do this, I say, okay, the theta is equal to the inverse tangent of 100 over 200. When you do that, it looks like this. You have the inverse tangent of 100 divided by 200, and you get 26.6 degrees. Now, you'd also want to define this 26.6 degrees because it could be southeast, northeast, and all also. So since I have north, since I have north, and since I have east, we want to go ahead and put an E there. So 26.6 degrees north of east.